So at the very early stages of this training, we looked at how data is formatted on local area networks using the Ethernet 2 standard and the IEEE 802 standard. But when it comes to wide area networks, we use other protocols, one of them being the high level data link control protocol, HDLC, and also the point-to-point protocol, PPP. So data is formatted and encapsulated at layer 2 on ones using these protocols. So in this particular chapter, we are going to learn how to establish HDLC encapsulation as the serial link layer protocol, how to change the DCE clock baud rate on a serial link, also how to establish PPP encapsulation, to implement PAP and also CHAP authentication on PPP links. So generally that is what we're going to be doing. Okay. So I have already implemented the topology. It's quite easy. So we have R1, we have R2 and R3. And if you can see, let me just go through this scenario. So as an expanding enterprise business, multiple branch offices have been established and are to be part of the company's administrative domain. So one solutions are required. As the network administrator, the company you have been tasked with establishing HDLC and PPP solutions at the edge router to be carried over some service provider network, possibly MPLS. However, the details of this have not been revealed to you since the service provider network remains outside of the scope of your task. So R2 is an edge router located at the headquarters. R1 and R3 are located in the office branches, in the branch offices. So the HQ and the branches need to be established as a single administrative domain, so they can be able to communicate with each other, R1, R2, R3, as if they are within the same local area network. So use HDLC and PPP on the one links and establish authentication as a simple security measure. So let's begin with step one. Step one is preparing the environment, really just renaming the routers. Then step two is cleaning up the previous configurations. We're using, we're actually using new routers, so we don't need to do step two. Then step three is configuring the IP addresses for each of the serial interfaces. So as you can see, this line is dotted, meaning it's a serial interface, and in fact you can see the label here, serial 001, serial 001. So for serial interfaces, because we've not used it so far, you just click on the thunder icon there, then you come to this serial. So you pick this, then you connect it with a serial interface. The router that I've used on this particular lab is the generic router because it offers serial interfaces. I tried AR2220, but it does not have a serial interface, and I didn't want to add one. Okay, so let's go ahead and configure R1. So we configure the system name to R1. Let's also do the same for this guy. This one. I have 3. Okay, and then we go ahead and configure the serial interface on R1. So int s0/0/1, IP address 10.0.12.1/24. Once we're done with that, we can go to the interface on R2. So on R2, we can go into int 0/0/1. Then we configure the IP address 10.0.12.2/24. We also go to int serial 002. We configure the IP address 10.0.23.2/24. So once we are done with that, we can go to R3 and also configure the IP address for the serial interface 002. So IP add 10.0.23.3/24. Okay. So that was what we were supposed to do up to step number 3. So we go to step number 4. On step number 4, we are required to enable HDLC on the serial interfaces. On the serial interfaces, how to do that is by simply doing link protocol HDLC. So you go to that particular interface, then you do link protocol HDLC. Now, before we do that, I just want to show you that the directly connected interfaces, we're still going to be able to ping. So for example, we can ping R2 from R1, 10.0 on the directly connected interface. Okay, what just happened? Okay, let me just confirm. Display IP int brief. Oh, sorry, I configured gigabit Ethernet instead of the serial interface on R2. So I'll need to undo that. So int gigabit 001 undo IP address 10.0.12. Good. Display this. So I've removed that. So I was supposed to do serial. Int serial 001 IP address 10.0.12.224. Okay, so now the ping should work from R1. So you see it works even though we've not configured any protocol between the routers. Reason being, by default, if we do display interface serial 0/0/1, if we do serial 0/0/1, we can actually see that the state is up of that serial interface and also the line protocol is up. Reason being, by default, the link protocol, the link layer protocol that is being used is PPP. So it's already working. You can see that IPCP negotiation has already been done. LCP negotiation has also been done. So the link control protocol, the IPCP, IP control protocol negotiations have already been done. So that's why we are able to ping. I can also ping R3 from here. So I can ping 10.0.23.3. So directly connected networks, we should be able to ping. So now let's go ahead and configure. Let's go ahead and configure HDLC. So you simply go into the serial interface and do link protocol ? To see the available link protocols. So some of the traditional link protocols that we no longer use include ATM and frame relay. We no longer use them because of their challenges in terms of speeds. So they cannot be able to support the requirement of today's network. So really what we are using mostly is either HDLC or PPP. The other one that was quite popular was the time division multiplexer, TDM. So for us, we want to specify on this serial link that we want to use HDLC, like that. So it's going to ask you, do you really want to do that? Then we do yes. So a number of things are happening there. And now, if I try to ping router 2, if I try to ping router 2 at this point, the ping is going to fail. So anytime peering interfaces are using different protocols, because R2 is using PPP, and we've just configured HDLC on R1, then they cannot be able to communicate. So let's go ahead and also implement HDLC on router 2. So you see here, IPCP has failed. The line protocol IPCP on the interface has entered the down state. It has failed, so it will simply go down to the down state on router 2 because we've configured router 1 to use HDLC. So let's go ahead and configure the serial interface on R2 with HDLC. So enter, yes, so Y, and then, so now I should be able to ping, R1. So 1.2.1. You see, now I should be able to ping R1. Let's also configure the other serial interface. So 0.0.2 with the link protocol of HDLC. Yes. Then we go ahead and do the same on R3. So on R3 again, we want to enable the link protocol as HDLC. So do you want to? Yes. Good. So how to confirm whether it's working? From R3 we can ping R2 on serial interface 0.0.2. So 23.2. So whenever you configure the same one link layer protocol, then it should work. Okay, so let's go on. So after verifying, we are supposed to verify so that we check that indeed the link layer protocol has changed from PPP to HDLC. So let's do that. We can do it on R1. So display interface serial 0/0/1. So we should see that the line protocol is up. And here we can see that the link layer protocol that is being used now is HDLC on that particular serial interface. Okay. We've already tested the connectivity and we've seen that it's working. Now the next thing we want to do is to use OSPF. We want to enable OSPF between these routers so that they can share their routes. But unfortunately, I don't know what's happening with my machine. When I'm using the generic router, OSPF doesn't work. They fail to form the neighbor relationships, OSPF neighbor relationship. I don't know why. So really, we want to enable OSPF so that R1 can be able to ping R3, because as it is right now, R1 cannot ping R3. We cannot be able to ping R3 because in our routing table, we really do not have the entry for that particular network 2.3. Oh, sorry, I did the wrong ping there. It's supposed to be 2.3. So it cannot really work. So I'll just do Control C to exit that particular ping. Okay. So instead of doing OSPF, let me try and configure a static route between R1 and R3. So I'll just do IP route static. Then the network for R3 is this one, flash 24. The next hop is 10.0.12.2, which is the interface on R2. Then I'll also do the same on R3. So instead of using OSPF, I'm using static route. So I'll also do IP static route static. Sorry, IP route static. Then I'll do 10.0.12.0 24. The next hop for R3 should be R2 interface.2 there. Okay, so once I do that, I should be able to ping R1's interface. So 10.0.12.1. So I should be able to do it. So in this particular step on configuring OSPF, we just wanted to make sure that the remote networks can communicate via the headquarters. So that's why we configured OSPF, but my ENSP has an issue. So that's why I have configured a static route. So I hope you understand that. So if we go to display IP routing table on R1, we should actually see, or even here, display IP routing table. We should see the route. We should see the route to R1, to that particular network from R3, and that is the next hop. Okay, so the next thing we're supposed to do, we've already run the ping, so now we are supposed to manage the serial connection. So here we want to view the type of the cable connected to the serial interface. We also want to look at the interface status, the clock frequency, and we are supposed to change the clock frequency. Again, in this particular lab, unfortunately, this VRP version does not display these particular details. So let me just do it on R1. So if I do display int serial 001, so you can see that it only shows the line protocol, the link layer protocol, and the current system time. So after that current system time, I think whoever made this used a different VRP version. So for us, it doesn't show us these particular details which we were supposed to actually see. So my assumption is that the default baud rate is 64,000 bits per second. We can see that this interface is the DCE. We know that when we are using synchronous mode, when you're using synchronous, HDLC can support both synchronous and asynchronous communication. Synchronous employs what we call a clocking mechanism. So one of the interface acts as the data communicating equipment and provides the clock. So the clock type, for example, the cable type we can see here is V35. The clock mode is DCE clock 1 or something there. Okay, so we want to change the clock frequency on the link between R1 and R2 to 28,000 bits per second. So this operation must be performed on the DCE. So let me just see whether we can see whether R1 is the DCE. Was there somewhere? No. It doesn't. It doesn't show. Okay, it's okay. So let's just go ahead and configure that particular baud rate. How to do that? We go into the interface. So interface serial 0 stroke 0 stroke 1 on R1. Then we do will it be able to baud rate? Then we want 128,000. Okay, so this does not even understand the command baud rates. Okay, so we're just going to skip this particular step on configuring baud rate. After all, that's the only bit that they talk about it, and thereafter we were supposed to confirm that the baud rate has changed, but unfortunately in this router that I'm using, it does not support the changing of the baud rate. Okay, so that is it about HDLC. Now we want to configure PPP on these serial interfaces. So we change it on R1. After that, we change it on R2 interfaces S001 and S002. Then we change it on S3. Then after that, we test the link connectivity, and we should be able to ping. Each other. Okay, so before we do that, I just want to enable a data capture. Let me see if I can do a data capture here. Start data capture. Choose link layer type. Let's choose PPP. Okay, so as that opens up, let's go ahead and change the link layer protocol here to PPP. Do you want to do this? Yes. Let's go ahead and also change the link layer here. So we go into interface serial 001. We change the link layer protocol to PPP. Yes. We also go into int serial 002 link layer protocol PPP. Okay. Then we also go to R3 int serial 002. We change the link layer into PPP like that. Do you want to do it? Yes. Okay, so we can test the connectivity, for example, between R3 and R2. We can do ping 10.0.23.2. So because both interfaces are using the same, it should work. We can also ping here. We ping R1 10.0.12.1. So if we're able to reach it, it means both interfaces are using PPP. And to confirm that the interface are using PPP, we can even display one of them. So display int serial 0/0/1. So we can see that the link layer protocol now has changed from HDLC to PPP. Okay, so let's see what has been captured. So you see, when we changed the protocol to PPP, are you seeing the PPP LCP packets, the configuration request? And you know what the configuration request does? So if we open the packet here, we can see, for example, some of the parameters for PPP packet. For example, the maximum receive unit MRU is 1500. We can also see the magic number, which is a randomly generated number that is used to ensure that we don't have loops within our PPP network. So this is a PPP LCP header. So those are some of the things we're seeing there, and we can see that on the protocol header, this is an LCP. So I just wanted to do that capture so that I can show you some of these things that you already learned in the theory class. So we have the request and the reply and so on and so forth. Okay, so let's go ahead and see what's the next thing we're supposed to do. So we're supposed to check the routing entries. So they're saying after PPP configuration is complete, routers establish connections at the data link layer. So the local device sends a route to the peer device. The route contains the interface IP address and a 32-bit mask. So let's try and do that on R2. I like that white background, so that's why I'm going there. So display IP routing table. So this is the interface IP address with a 32-bit with a 32-bit mask that is sent by PPP and therefore also installed inside the routing table. Similarly, from R2 to R3, we have this one here. So before we had PPP, these entries were actually not there in the routing table. Okay. So now let's go ahead and configure PPP PAP authentication between R1 and R2. And then between R2 and R3, we are going to configure CHAP. Okay, so configure PPP authentication between R1 and R2. And we are supposed to set R1 as the authenticator. So the authenticator is the person who will authenticate the other person, and the other person is called the authenticated. So in this case, R2 is the authenticated. So let's go ahead in R1, go to that particular serial interface. So here we are on R2. So in R1, we are already in the serial interface. So we specify the PPP authentication mode. If I do question mark, you can see we have two, PAP and CHAP. So we enable PAP as the authentication mode, PPP authentication mode. Then after that, we can quit and we can create a user using AAA on R1. So the command is local user, and then the username of this person, Huawei, password cipher. We want the password to be Huawei123. So we've created a user. The next thing is to enable this user to be able to use PPP. So we use the command local user service type. Let me just see. Local user. And then the username of that particular person, then service type, then we enable them to use PPP. So with that, we are done with the process on the authenticator. Let's now go to the authenticated. So in the authenticated, we need to go to that interface. So 001. So int 001. So we are supposed to use the command PPP. Just a moment. Okay. So on R2, we use the command PPP pap local user, the username of that person, then the password cipher, then the password of that particular person. So PPP pap local user Huawei, password cipher Huawei 123. So now this is the authenticated. Now we can actually, because we did a data capture, we can actually see. Let me see. Okay, we can simulate that with the other connection. Let's just go on. So here, the next thing we're supposed to do is after R2 sends an authentication. So after we've configured that particular R2 with that command, R2 sends an authentication request to R1. R1 sends a response to R2 requesting R2 to use PAP authentication, following which R2 will send its password to R1. So in order to see it, that particular, we need to use the debugging command. So debugging will simply show us the interaction between the two routers. So the command is debugging PPP pap packet. Then you enable terminal debugging and you display debugging. So once you do that, you will be required to shut down the interface on R1, then restart it so that authentication can be captured. So for us, we are actually using, instead of using this debugging, we are capturing the packets using Wireshark. So we'll want to evaluate what we see from Wireshark. So what we're supposed to do right now is to shut down this serial interface on R1. So int S0/0/1. So we can shut it down. Then after that, we can undo shut. So after we restart it, LCP will take place again. So you see here, this particular packet is an authenticate request. And we can see the authenticate acknowledge. One thing with PPP, one thing with PAP is that the password and the username are visible, so it doesn't encrypt them as they are being sent between R1 and R2. So you can see that. So we've seen the authenticate request and the authenticate acknowledge. So R2 is the one that is sending. If we look here, let me see. R2 is the one that is sending the request. The authenticated is the one that sends the request. Can we be able to see any data here? The frame. Okay. Then the next packet here, so I cannot be able to see here any information that will prove that R2 is the one that is sending, but R2 is the authenticated, so it's the one that sends the authenticate request, sends the username, that is what you're seeing here, PID and the password. Then R1 will respond with an authenticate acknowledge. So welcome to use blah blah blah. So acknowledge, it's an acknowledgement. So that is really what happens between R1 and R2 when we configure PPP, PAP, PPP Password Authentication Protocol. So let's go ahead and now do, we want now to enable CHAP authentication between R2 and R3. So we can close this down. so that we do a data capture. We now want to do a data capture between R2 and R3. So let me just start a data capture there. Again, it's PPP. Okay. So we want to do CHAP between R2 and R3. So let's look at the command. So we simply go into the interface. Then we use the command PPP authentication mode CHAP. So we do this. Then R3 is the authenticator. So we create a user on R3. We create a user on R3 and enable the PPP service on this particular router. So then we go to R2, also enable CHAP by specifying the username and the password of this particular person. So that is what we want to do. So let's begin with R2. So we go into interface, or we are already in interface serial 002 that is connecting to R3. So we do PPP authentication mode CHAP. Then we go ahead and create a user. So we go into AAA, local user Huawei, password cipher Huawei 123. Oh, sorry, I did a 1, 2, 3. Okay, so Huawei 123. Then after that, we enable the service, the PPP service for this user. So local user Huawei, service type PPP, like that. So once we are done with that, we now go to this guy who is R3. So far, no authentication packets have been captured. So now we go to R3 and configure this particular username and password. So on R3, I think I've configured R2 as the authenticator. So I think I confused there. But just let's go ahead and then configure this guy as the. Let's configure R3 int 00. Let me see the interface 02. Okay, so int 002 2. Okay, so let's go ahead and configure R3 as the client. So PPP CHAP user Huawei, then PPP CHAP password cipher Huawei 123, like that. So we've configured R3 as the client, as the authenticated, and R2 as the authenticator. So now we on R2 we can get into that serial interface 2 and shut it down. So after we shut it down, we are at 100. After we shut it down, we can undo shut. So when we restart that particular interface, PPP LCP will ensue again. So let's just say, good. So you see the challenge. The challenge has been sent. The challenge has been sent, And as you can see, unlike PPP, in CHAP, the password is encrypted. So you see the value here is actually the password. And it's like we configured different, we actually configured different passwords. So that's why it's failing. It's failing here. So I think in the first one I configured Huawei, and here I've configured Huawei 123. So I can still change that so that you can see. So this is a failure. So I'm just showing you this to show you that we have the three-way. So you have challenge, response, and whether it's an access or whether it's a success or a fail. So we've seen that this is actually a fail. And after several trial, then they're going to terminate. They're going to stop trying to connect to each other. So let me just try and reconfigure that particular password. This password. Let me try and do Huawei. Okay. So let me shut it, then undo, shut. Let's see. Oh, still a failure.
What you did was Huawei, then the 123, just redo Huawei 123 in full. The other one was not cipher. The 123 was not cipher.
Oh, the other one was not cipher.
Yeah, that is only Huawei.
Yeah. By the way, and I thought I just changed this one to Huawei too. PPP CHAP, password cipher, or maybe let me see. PPP CHAP user Huawei. PPP. Huawei. Shut. Undo shut. There's a password that I misconfigured, but generally that is it about. If I had done both passwords correctly, then the negotiation would have been successful. But I think I did configure the password wrongly in one of the ends. So I think that is it about this particular lab. So we go ahead and do